backing up SQL Server. In this nugget, we're going to start by talking about the SQL Server backup philosophy. We'll also be talking about the different recovery models that you can use in your database. We'll look at the compression options for backups and the different backup types, including full, differential, log, and snapshot backup types. I'll show you how to schedule a backup to occur on a regular basis. I'll show you how to, instead of backing up an entire database, how to back up just a particular file or a particular file group. We'll look at how to have backups be verified, and we will look at some of the interactions between database mirroring and the backup and restore system. The first thing we need to talk about is the basic scheme or philosophy behind SQL Server backups. So let's say we have our database, and of course as part of that database we have a transaction log. Now, data is constantly being written or changed in the database. So we'll say we have change A, B, and C. And in order for that to happen, those changes had to go into the transaction log, A, B, and C. So when we make a full backup of the database, let's do this in a different color. Our full backup has A, B, and C in it. So this will be our full backup from that particular day. At the time that backup is made, we're going to sort of draw a line in the transaction log, letting us know that everything above the line has been safely backed up. And so now we proceed, we make change D and E, and those go into the transaction log. And periodically we may want to back up the transaction log. And so this transaction log backup is only going to have the things that have changed since the last full backup. So that'll just be change D and E. So now we'll continue with the transaction log, and we'll write change F and G, and that goes into the database. And now all of a sudden the database crashes. So we've lost our database. Well, now what do? First, we need to restore our full database backup. That gets us data A, B, and C. Next, we're going to restore any transaction log backups that were made since the full database backup. That gets us D and E. Before we even begin restoring, though, we're going to do something called a transaction log tail backup. That's going to grab just the stuff from the transaction log that hasn't been backed up, put it into a separate file, and that'll be the third one we restore. So we start by doing this, that's step 0, do this transaction log tail backup, then we restore our full backup, then we restore our transaction logs, and then we restore that transaction log tail. And that gets us back right up to where we needed to be. And that brings essentially all of our data back to the database. We've lost nothing. Now, if we had lost the database and we lost the transaction log, then we're not going to be able to get that tail back up, and so we will be missing data F and G, the things that have happened since our last transaction log backup. So that's sort of the general philosophy behind backups in SQL Server. Now, SQL Server itself supports 3 different types of backup. A full backup grabs the entire database and clears the transaction log for us because those things are now safe. A differential backup is only the things in the database that have changed since the last full backup. And a log backup is just the transaction log. There is a special type of backup technique in SQL Server called a snapshot. The built-in normal, typical, run-of-the-mill backups that we're talking about with SQL Server are not snapshot backups. Snapshot backups are actually very special. They require third-party software or hardware or software and hardware support. Exactly how the snapshot backup is implemented depends on what that third party is doing. One example is to say we have a hardware vendor who's provided us with 2 mirrored disks, disk 0 and disk 1. We've got SQL Server automatically writing our data to disk 0, and the underlying hardware mirroring is going to be making a copy of that on disk 1. When we tell SQL Server to do a snapshot backup, the hardware vendor can choose to temporarily break the mirror. That sort of locks our copy in its current state and time. It'll make a copy of that, which becomes our backup, and then it will re-establish the mirror. And this all happens very, very fast, nearly instantaneously, and it requires very little overhead on SQL Server because SQL Server isn't actually doing very much work. It also allows the original database to continue being used, although any changes made to it while that mirror is broken are not captured in the backup. Once the mirror is reestablished, it'll re-mirror the database, and this copy over here will be back up to date. If you're using SQL Server's volume shadow copy service writer, it uses this snapshot technique, which does require third-party hardware or software, or a combination of hardware and software. Normal SQL Server backups just grab the database as it sits and dump it to a backup file, which you might have as a BAK file, or if it's a log backup, you might come up with a BLG or some other. You can put whatever file name extension you want. It's important to note that the snapshot only works with third-party hardware and software support. It is also important to understand that SQL Server databases themselves can operate in one of three different recovery modes: simple, bulk logged, or full. In the simple recovery mode, there is no transaction log. That means if you have a full copy of the database and it's up to date, you're fine. If you have a full backup of the database and then you go for a week without doing another backup, any changes made are not retained, they're not recoverable. You lose it all. This is suitable for databases that are largely read-only, that don't have many changes made, so you don't need to make a backup of them very often. If something happens to the database, you can just go grab your backup and it'll still be up to date. Bulk logged does use a transaction log, and it uses it for most transactions, but it does not use it for bulk transactions, either using the bulk copy utilities or other types of bulk inserts, statements like select into. There are certain types of statements within SQL that do not get fully logged. What this does is it allows those statements to operate with a higher level of performance, and since those aren't typical things that you do every single day, the idea is you put the database into bulk logged mode, you undergo the bulk transaction, and you, the administrator, know that those things weren't backed up in the transaction log, and so you immediately back the database up right then and there, so you don't lose those bulk things that you just did. In the full recovery model, you have a T-log, transaction log for everything. And that's the model that we sort of just drew out. SQL Server Books Online does sort of go into these. If you look at the recovery model overview topic, it'll explain the difference between the simple, the full, and the bulk logged, and it will give you a list of the operations that can be minimally logged, or the ones that don't go into the transaction log. Bulk import operations using the BCP utility, or bulk insert, or select into statements. Write text and update text statements under certain circumstances. So this sort of describes the operations that wouldn't go into the log. Now, how do you set up that recovery model? Well, it's simply a property of the database. If we look at options, we have a recovery model: full, bulk logged, or simple. Most transactional databases are going to run in full. One reason you might want to switch to bulk logged is if you are going to do a large bulk insert of data. Rather than having each individual item logged, you might want to have SQL Server not log them all. Go ahead and insert them all, get the higher performance, prevents your transaction log from filling up very quickly, and then you know to immediately take a full file backup of the database so that you don't lose any of those things if the database runs into a problem. Something else that's important to note with that snapshot type that I told you is that it does not automatically provide support for the file stream data type. SQL Server just keeps those file stream files off in a separate location, and they're not included in that snapshot, which relies on usually breaking a mirror of the database itself. Now, there's one other set of considerations that we have to think about, and that's when we're doing database mirroring. Now, we talked about this in the previous nugget, and that's where we have an instance A that's running a database, and we have a second instance B that is getting transactions from A and using it to create a duplicate copy of the database in that other instance. Backups and restores have got a few restrictions. Your secondary, your mirror, cannot be backed up. And that kind of makes sense. It in itself is a backup, so you're not going to take backups of it. You cannot do a restore to your primary. And that also kind of makes sense. You shouldn't need to do a restore because you've got the mirror over here that you're going to use instead of doing a restore. So those are a couple of restrictions when you're using database mirroring. Again, the help online, the help topics, includes some of the caveats around mirroring. Again, backup and restore of the mirror databases are not allowed. Backup of the principal database is allowed, but you cannot do a backup log with no recovery. That is the statement that does a transaction log tail backup that we talked about earlier. And you cannot restore the principal database. So let's talk about those tail backups real quick. We'll see this in the GUI, but I want to show you, if you look up tail log backups in the help, you'll find the command backup log, whatever the database name is, to whatever your backup is called, with no recovery. That does the tail backup. And it also places the database into a mode that you can then go and grab all of your backups, get them together, get yourself situated, and start a restore. Typically, you're only going to do a tail log backup just prior to doing a restore. So now let's look in the graphical user interface. Right-click a database, go to Tasks, and select Backup. And we can look at some of our backup options. Let's choose the database we're going to back up. It's in a full recovery model. We can choose to do a full, differential, or transaction log backup, and the options will change depending on which one of these you select. We can either back up the entire database, or we can choose just to select particular files or file groups. Notice that we've got the entire database. We can also back up just the file streams portion. This database does have the file stream data type enabled. If you do the entire backup of the entire database, you get everything. So tell it where you want it to go. You can indicate when the backup set will expire. And what that does is it prevents you from using an expired backup set in a restore. If you know, for example, that you're going to do a full backup of your database every week, then you might set each one to expire after a week. That way, if you try to use an old backup in a restore by mistake, SQL Server will be able to warn you. And of course, you've got the option to back up to disk or to tape if you have a tape drive attached to the local SQL Server computer. Now, if we go to the Options tab, depending on what type of backup you're doing, you'll get different options. You can back up to an existing media set, and you can append the existing backup data to the existing media set, which means if you're writing to a file, the file can actually contain multiple backups. Or you can say, I want to overwrite everything and start from scratch. You can also create a new media set, and you're typically going to use these when you're working with tapes. Once the backup is finished, you can choose to verify it, perform a checksum on data before actually writing it to the media, and if you run into an error, continue with the backup anyway. Had we selected a transaction log backup, these additional options would have been enabled. At the end of the transaction log backup, we can choose to empty out the transaction log, to truncate it, to clear it, and that's a great thing to do. It'll free up some space in the transaction log, and we're not losing anything because we've just backed up everything that we're clearing out. Or we can say, back up the tail of the log and leave the database in a state for recovery. In other words, grab the last few things in the log that haven't been backed up someplace already, put the database into recovery mode, and we're going to start restoring database backups as our next step. So that's how to do this within the graphical user interface. The other thing you might want to be able to do is to schedule a backup, and you can certainly do that. There are several different ways. One way is to use this graphical user interface to get everything configured the way you want, and then script that to a new query window, or script it directly to a job. Jobs all take place within SQL Server Agent. So the next thing that'll come up is the New Job dialog box. It'll allow you to create a name for this job, decide who owns it. If you want to categorize your jobs, you can do that. We'll call it database maintenance. And the job step that will be inserted here is the backup instructions that you just configured on that previous dialog box. So once you're done configuring that job step, you can set up a schedule. Let's do this daily. This is going to recur on a daily basis. We're going to do it every day of the week at, we'll say, 1 a.m., starting today and never ending. You can have alerts go out. You can get notifications to email, to a pager using the net send functionality, right to the Windows application log, or you can automatically delete the job when it succeeds. On a recurring backup, you're not usually going to want to do that, though. And finally, with a job, and this is something we'll talk about later when we talk about SQL Server Agent, you can actually target this to the local server or to multiple remote servers if you have enrolled remote servers in job targeting. Again, something we'll get to later. So you can create a job to schedule this to occur on a regular basis, or you can just do an on-demand backup right now. And this is the location that it would write to by default. I'll just hit OK. And it gives me an error. It can't process the database because it's in use by this session. And that means that I'm actually connected to that database. So it's recommending that rather than connecting to that database, I connect to the master database, and I can do tasks backup from there and just select the database I want. And that way I'm not holding the database open and locked. That's just kind of a neat little caveat that it's good to know about when that happens to you. One last option we should look at are your compression options. Let's go ahead and open up the backup dialog box again. And if you're on a small screen resolution like I am here in the lab, it can take a little bit of finagling to see this. It's actually at the bottom of the Options tab, and you can see that you can either have it use the server's default setting for compression, or force it to compress the backup, or force it to not compress the backup. And that's definitely a useful little trick to have. In this nugget, we looked at the different recovery models within SQL, including full, bulk logged, and simple recovery models. And we talked about the impact those have on your recovery options. We looked at the compression option for compressing your backups, making them a little smaller. Looked at the different backup types, full, differential, log, and then the third-party supported snapshot. Looked at how to schedule backups. You saw how to back up just a file or group of files in SQL Server rather than the entire database. And you saw how to verify the backup as it's being made. We also talked about the interactions between database mirroring and backups. I hope this has been informative for you, and I'd like to thank you for viewing.